Hello everyone, welcome to topic 13, which is on object-oriented programming. It's a very important programming paradigm which is typically tested during job interviews, internship interviews, so it's very useful. You learn it even though I'm not going to be testing you on it. I'm going to explain it so it's easy to follow. If you try to learn it on your own later, it's going to be more challenging. So take advantage of this video and the practical session where I'm going to be showing you how to implement these concepts in code. Again, this is your standard learning goals, outcome assessments, and activities. Feel free to read this. Object-oriented programming, like I said, is a programming paradigm which allows you to develop computer applications such that properties and behaviors are bundled into individual objects. Objects are nothing more than physical things like animal. If you're writing, say, a code for animating animals, for instance, or in petroleum engineering, a well could be an object. So these are physical things, and they could have properties or characteristics and behaviors. So these are two different things: properties and behaviors. Properties are characteristics for a person object. So we're giving an example of an object as a person. The characteristics of the person or the properties of the person include age, height, weight, and so on. And behaviors, on the other hand, are the actions the object can perform. And the actions a person can perform could include walking, talking, breathing, running. It could also include the actions that can be performed on the object. So for a well, it could include shortening the well. So these are verbs. That's the main difference. So behaviors are actions. They are usually verbs, like all of this. And properties are characteristics, and they are like those shown here. So properties, behaviors are bundled into individual objects. So for all the objects you'll be looking at in object-oriented programming, you will be seeing the properties of the object, and you'll be seeing the actions that the object can perform or that can be performed on the object. So for a well, you could have properties like initial flow rate, initial decline rate, cumulative production, the depth of the well. Those are all properties. They are like the features of the well. And for behaviors, like I said, they are actions. Actions the object can perform, or actions that can be performed on the object. So this includes shortening the well, producing from the well, injecting into the well, and so on. So object-oriented programming models real-world entities as software objects. So whenever you want to write a code, you think about the real-world entities, the nouns in the problem description, meaning like we're trying to model production rate for the production decline for all the wells in a field. So we already mentioned wells, right? So wells will be objects. Field could be an object. And that's how you think about your problem. You think about the nouns in there that you can make into objects, then you start to think about the properties of that object, then the behaviors, and you will create several objects which you will use throughout the code. It makes it very easy to manage large programming codes. So this is a different programming paradigm than what we've been doing so far. What we've been doing so far is called procedural programming. Procedural programming, as you can infer from the word procedural, means you're following a procedure. So you're going step by step. You execute one line of code, you go to the next. It's like you're writing your program like a recipe in the form of functions and code blocks that flow sequentially, line by line, starting from the beginning. Of course, if you have if statements, it's going to choose between the different paths of code execution, depending on the values in the if statement. If you have loops, you could keep repeating a portion of the block of code until you exhaust the loop and you continue. But in general, you're going from top down systematically. And the code is usually action oriented, like compute flow rate, compute cumulative production. Then after you are done computing these two, I say plot um, cumulative production, plot the flow rate. If you look at those previous labs you've been working on, I will sometimes enumerate the different steps, starting from 1, 2, 3 down, and you go from top to bottom. And that is all procedural programming. Object-oriented programming isn't necessarily that way. You start up thinking about the object and defining the properties of the object and the actions that you can perform on the object. So objects are the center of OOP, object-oriented programming paradigm, while actions are the center of procedural programming paradigm. Python allows you to do both. So it's a multi-paradigm programming language, and that gives you the flexibility to choose the programming paradigm that suits the problem you're working on. It also allows you to mix the different paradigms in one program and switch from one paradigm to another as your program evolves. So as you begin to add more lines of code, you can switch from one programming paradigm to another, and you can just do both in one code. Now we move on to some concepts in object-oriented programming, classes. So standard data structures in Python, like float, which you're familiar with now, integer, strings, list, are designed to represent simple things like amount of money, that will be float, production rates will be float, well names will be strings. These are very specific in what they do. What if you want to keep track of cumulative production, initial flow rate, well names, and on for different wells, for 20 wells, for instance? Yes, you can use a list, right? You can have a list of these three values for all the wells. But that could get very messy if some of these values are missing for some of those wells, right? Or if you change your mind and you want to add more properties later, using lists to maintain this kind of data will not be particularly efficient in this kind of case. So this is why we use classes. Classes can allow you define common properties for the object, and you don't have to specify all of them originally. You can make those specifications for the different wells as those data become available. Or some wells, maybe they don't have initial production rate because it's an exploration well, for instance. So those wells don't need to provide this value, and classes give you that flexibility. So what are classes? Why do you need classes? We use classes to create user-defined data structures. So we are going to create our own data structures instead of using the primitive data structures like floats, integers, which I showed earlier. We can create our own data structures that can contain arbitrary information, meaning information we decide, information we choose about the object. So in the case of a well, we could create a well class. So I'm just showing you this function which can contain any argument or no argument. So this is a well class, and we're going to use it to track the properties of that class. And those properties could include the ID of the well, cumulative production, initial production rate, initial decline if we want, the B exponent, whether the well is a producer or injector or exploration well, meaning well type. So all of those can be bundled as properties into the objects we create using the class. So we use classes to create objects. A class is a blueprint for how something, in this case an object, should be defined, but it doesn't necessarily contain anything by itself. The classical example of this is it's like your architectural plan. It's the plan of the building, but it's not a building, right? It's just like a blueprint on how to build the actual home or building. So that's what classes are. They shouldn't be confused with the object. You use the plan to build the home. You use the class to construct an object. So the well class can specify these properties are necessary for defining the actual well object, but it may not actually state what each well's ID, cumulative production, and initial flow rate is. It specifies what is needed to create the object, but it doesn't give you the values in those properties, basically. So think of it as an idea for how an object should be defined. The object will be well A, well B, well C, the actual wells, which can be mapped to physical production or injection wells on the field. But the classes are just like a template for building those well objects in code. So an object is an instance of a class as a classical definition. So you can have multiple objects defined from one class. You can have hundreds of wells initialized from a well class. So the well object should not be confused with the well class. The well class example, well A, is an actual well in an oil field, which will be the object, and this is the class. It's not an idea, but a specific well that has a name and these other properties. So another way to think about a class is like it's a form, a questionnaire, which I can give to everyone in this class. And in that questionnaire, I'm asking you to fill out your information. So everyone will fill some of the questions. You don't have to fill all of them. The form itself doesn't correspond to any specific student, but when it's filled, each of the filled forms correspond to a particular student. So the specific copy for each student can be seen like an instance of the class, and it contains information relevant to the student who fills that form. So I can have you all fill the form, and I have 13 instances of the form because I have 13 students in the class. But without the form as a guide, I mean, there is no questionnaire, right? Meaning there is no consistency in the information you all will be filling. So in the same vein, when writing object-oriented code, before you create your object, you need to first think about the common features that will be present in the class. So for a well, the common features could include some of these, right? Which I've mentioned before, the properties of the well, and also the actions that you can perform on all of the wells. Those are the blueprints that we will use to create